Hi, Math 2 students. So today we're going to pick up where we left off for solving right triangles. Okay, so yesterday we learned how to solve for sides of a right triangle. And in order to do that, we needed to be given at least one of the angles. Okay, so now let's talk about what happens when you're not given any of the angles. Okay, so they want us to find the missing angles of a right triangle. So let's go ahead. We're going to start out with angle A. This is our angle of interest. So we have three sides here. So we actually have a ton of different, we could use any of the trig functions, right? We could label 9 as our opposite, 41 is our hypotenuse, and 40 is our adjacent. So we have all of them, so we could use any of the trig functions. Let's go ahead, let's just use sine, all right? So we're gonna set up our ratio. So sine of A. I want you to tell me what sine of A is. This is actually what we did on the first day. Go ahead and tell me what the ratio would be for sine of A. So for sine of A, it's going to be opposite over hypotenuse, so it's going to be 9 over 41. All right? But this doesn't tell us what the angle is, right? I have to try and get this A by itself. Well, how do I get the A by itself? I can't divide by sine because the A is like inside of that function. So we have to use something called sine inverse. We're going to use the inverse trig functions. And what happens is, if you do sine inverse of sine of A, what it does is it undoes the sine, okay? And remember, what you do to one side, you have to do to the other. So we have to do the sine inverse of this side. All right. So since the sine inverse undoes the original sine, the A is now by itself. And then to get this, we have to go to our calculator. Now, pay close attention. You got to make sure you know how to plug this in on your calculator. Of course, make sure you are in degree mode. We're going to go ahead and do sine inverse. So to get the sine inverse button, you have to press the second key, then the sine button. So again, to get the sine inverse function, you press the second key, then the sine button. You're going to type in 9 divided by 41, and you should get 12.68. All right, so we got that A is 12.68. Now, let's go ahead and let's talk about how we could find B. It's actually super easy to find B now. We've got that angle A is 12.68. We got that angle C is 90, right? So it should be really easy to find angle B. We would do 180 minus 12.68 minus 90. And they tell us that angle B should be 77.32. However, I want to try and solve for angle B using trig functions. All right, so let's make sure that it works. We're gonna check our method here. So now we're looking at B. So now our opposite and our adjacent are actually going to switch. Our opposite is now 40 and our adjacent is 9. Okay, and we can go ahead and try sine. Let's go ahead and we'll do sine again. So we're going to do sine of B equals our opposite, which is 40, over our adjacent, which is 41. So then if we're trying to get B by itself, we need to do the opposite of sine, which is sine inverse. And then what you do to one side, you do to the other. All right, so we end up with B equals, and we need to calculate it. So we're going to do second sine inverse. We're going to do 40 over 41. Oh, well, I did the wrong thing. Second sine, I did a regular. 40 over 41 gives me 77.3. So that's looking pretty good, right? That checks out. So kind of the big takeaway here is when you have to calculate for an angle, you could go through and do it this way. Another way is you could just go straight to the inverse function. Whenever you're looking for an angle, you have to use the inverse function. So you could do sine inverse of opposite over hypotenuse. Actually, we should probably say to solve for an angle. We do sine inverse of opposite over hypotenuse. We could do cosine inverse of adjacent over hypotenuse. That's our ca. And we could do tangent inverse of opposite over adjacent. So again, to solve for an angle, you have to use the inverse functions. So let's go ahead and try some of the examples here. So here they want us to solve for angle x. So let's go ahead and mark angle x. All right, and if we mark angle x, 12 is our O, 10 is our adjacent, right? So if we have opposite and adjacent, what trig function do I need to use? Am I going to use sine, tangent, or cosine? So for opposite and adjacent, we're going to use tangent. Now, let's go ahead. We're going to say tangent of x equals our opposite, which is 12, over our adjacent, which is 10. Now, like I said, when you're solving for the angle, you could go right into these formulas I put up here. So we actually could go right to this, tangent inverse of opposite over adjacent. Let's just do that. So we're going to do second tangent inverse of 12 over 10. And you should get 50.19. And then the quickest way to find angle Z, let's just do 180 minus 90 minus 50.19. That's going to give us 39.81. Could you use trig to find angle Z? Yeah, right? In this example up here, we did both. We solved using 180 minus, and then we also solved using trig. Either way is going to work. Personally, I think that the 180 minus is a heck of a lot faster, so that's what I would do. All right, now we're going to have to solve for xz. All right, so let's put an x here. Or we already had an x. Let's put an a there. All right, so that is our hypotenuse, right? So we have to either use the x or the z angle. You cannot use 90 when you're setting up these proportions. So let's go ahead. We're trying to solve for A, which is our hypotenuse. And you could use either your adjacent or your opposite. It doesn't matter. Let's go ahead. Let's use our adjacent. All right. So if I'm using adjacent and my hypotenuse, which trig function am I going to use? That is going to be cosine, right? So I'm going to do cosine of my angle, which is 50.19, equals my adjacent, which is 10, over my hypotenuse, which I don't know. I guess I put an A there, didn't I? Ha ha ha. All right, so then this is where we do that cross multiplication. We get, sorry, I'm gonna run out of space apparently, whoops. You would get A cosine of 50.919 equals 10. And then you'd have to divide by cosine 50.19. So we would get that that length is equal to 10 divided by cosine of 50.19. So we could just plug that into our calculators. 10 divided by cosine 50.19. And go ahead and tell me what you get for that. So you should get 15.61. All right. Don't forget when you're solving for the sides, you use the regular cosine function. All right, so let's go ahead and try this next one. So first they want us to solve for angle R. So we put a little marking there. This is our theta. We were given our opposite and our hypotenuse. So we're going to have to use sine to solve for angle R. So I want you to go ahead and solve for angle R for me and tell me what you get. So since we're looking for an angle, we can use the inverse function. We can go straight there. So we're going to go sine inverse of our opposite, which is 25, over our hypotenuse, which is 32. Which is going to give us 51.37, or actually 0.38. All right. Now you should be able to solve for angle T. So go ahead and solve for angle T. So to get angle T, we're just going to do 180 minus 90 minus 51.38, which is going to give us 38.62. All right, and then we got to solve for our S. Now, I do want to point out you could use Pythagorean theorem here. All right, so why don't we go ahead, let's do a Pythagorean theorem one. instead of using trig, we could use Pythagorean theorem. So we'll say that this is our A, this will be our B, and this will be our C. Your C always has to be your hypotenuse, all right? So we know that A squared plus our B squared, which is 25, equals our C squared, which is 32. So we get A squared plus 225 equals, and then 32 squared. It's going to give us 1024. We're going to minus 225. Or actually, hold on. No, I think that's wrong. 25 times 25. I did 15 squared. I'm sorry. It should be 625. My bad. So 1024 minus 625 is going to give us 399. So then you just take the square root of both. Let's see, square root of, oops, sorry. So we'd get square root of 399 is going to give us 19.97. So that's how I did it using Pythagorean theorem. Let's go ahead. Let's try it doing trig. Okay. So we said angle R is 51.38. Let's go ahead. Let's use tangent. I feel like I haven't used tangent in a while. So we're going to do opposite over adjacent. So we're going to do tangent of 51.38 equals our opposite, which is 25, whoops, over our adjacent, which is A. All right, so we're going to cross multiply. We get A tangent of 51.38 equals 25, and then we're going to divide by that. So we get A is 25 divided by tangent of 51.38. So let's plug that in. And we get the same number, right? So again, that shows how you can use Pythagorean theorem or trig.